Okay, I'm going to model rationalizing the denominator. First, I will use a monomial denominator. For example, if I had 3 divided by the square root of 2, I want to make sure that there is not a radical in the denominator, so I'm going to multiply by the square root of 2. And I multiply straight across. So numerator multiplied by numerator is going to be 3 square roots of 2. Denominator multiplied by denominator is going to be the square root of 4. The square root of 4 will reduce, so I will get 3 square roots of 2 divided by 2. And that's my answer. Another example, if I had the square root of 5/7, I can break that apart, be the square root of 5 divided by the square root of 7. Neither one of those can be reduced, so I'm going to go ahead and multiply by the square root of 7, because that's the denominator. Now when I multiply my numerator, the square root of 5 multiplied by the square root of 7 will be the square root of 35. And the square root of 7 multiplied by the square root of 7 will be the square root of 49. That will reduce to the square root of 35 over 7. And that's my answer. If I want to rationalize with a binomial denominator, I will need to use the conjugate of the denominator. For example, if I have 1 plus the square root of 3 divided by 2 minus the square root of 5. The denominator, 2 minus the square root of 5, has a conjugate, which would be 2 plus the square root of 5. But in order to keep everything the same, I have to multiply numerator and denominator by 2 plus the square root of 5. And this is where you're going to have to make sure you're careful. I'm going to have to multiply 1 and the 2 to get 2. 1 and the square root of 5 will give me plus the square root of 5. Square root of 3 multiplied by 2 would be plus 2 square roots of 3. And the square root of 3 multiplied by the square root of 5 will be plus the square root of 15. My denominator, when I multiply 2 multiplied by 2, will give me 4. 2 multiplied by the square root of 5 will be 2 plus 2 square roots of 5. Negative square root of 5 multiplied by 2 will be minus 2 square roots of 5. And negative square root of 5 multiplied by positive square root of 5 will be negative square root of 25. My numerator has nothing that can be reduced or combined, so I will leave that the way it is. And my denominator, the positive 2 square roots of 5 and the negative 2 square roots of 5 is going to be 0. This will be minus 5, so I'll have 4 minus 5. I can reduce that. There'll be 2 plus the square root of 5 plus 2 square roots of 3 plus the square root of 15 divided by negative 1. And it's just not proper to leave a negative 1 in the denominator, so I'm just going to reduce everything by dividing by negative 1. So I get negative 2 minus the square root of 5 minus 2 square roots of 3 minus the square root of 15. That's my answer. One more example. If I had 4 plus the square root of 6 divided by 5 plus the square root of 6. My conjugate will be the opposite sign of 5 plus the square root of 6. It will be 5 minus the square root of 6. So I'm going to choose my conjugate, 5 minus the square root of 6, and I'm going to multiply. 4 multiplied by 5 is 20. 4 multiplied by negative square root of 6 is negative 4 square roots of 6. Square root of 6 multiplied by 5 is plus 5 square root of 6. Square root of 6 multiplied by the square root of 6, it'll be minus the square root of 36, so minus 6. My denominator, I get 25. Minus 5 square roots of 6 and a plus 5 square roots of 6 is 0. So square root of 6 multiplied by negative square root of 6 will be minus 6. My numerator, I can combine like terms. So I have 20 minus 6 will give me 14. Negative 4 square roots of 6 plus 5 square roots of 6 would be plus 1 square root of 6. And my denominator, 25 minus 6, will be 19. It's okay to leave it like that, or I can reduce it as part of two fractions, 14 over 19 plus the square root of 6 over 19. Either answer is acceptable.